So we're on page 31. Just a reminder, you guys, sine, cosine, and tangent. Does anyone remember what their co-functions are? Which one goes with sine? Cosecant does. So cosecant goes with sine. We wish that it was secant so that the S's matches, but it doesn't. Anyone remember the abbreviation for that? CSC. Well done. Which one goes with cosine? Secant. Again, I wish that it was cosecant, but we can't have it all. What's that abbreviation? SEC. And finally, tangent. This one does make sense. Cotangent. Love it. And then that abbreviation? Great. COT. Love it. So we're not actually going to talk about those this unit. This section. We're actually talking their inverses, and inverses are different. Two different ways to write the inverse. You can say arc or something to the -1. So arc sine or inverse sine, arc cosine or inverse cosine, and arc tangent or inverse tan. Just curious, who would prefer the arc? How many people are like, oh, I'd probably say arc. How many people are going to put it to the -1? That's what I do because it's just less to write, personally. It's less to write, and the notation on your calculator, check it out. When you press second sign, it does the sign of the -1 notation. So I think that's what I do. But in AP Calc, they'll do both. So just want us to be versed in it. Anyone remember what inverses have in common? The inverse of a function, what do we know about their coordinates? They're flipped. You just switch the x and the y, right? What's the fancy word for the x? X coordinates, the fancy word? Oh, touche. In terms of the sine, cosine, tangent, you're right. In terms of domain and range, you remember which one's the x? Say it again. Domain is the x. So if it says, in other words, the domain, or we're just saying the x value of the function becomes the range of the inverse, and then conversely, the range of the function becomes the domain of the inverse, range being the y. Good call, though, Mr. Hen. Cosine is the x-coordinate. You're right. Something I'm not going to make us do is graph inverse functions. And let me tell you, I tutor some UA kids, and they've got to graph inverse functions, and it's miserable. And it's not a worry of mine for AP Calc, so we're moving on. Does that sound good? I just wanted you to see what the inverse functions look like. Again, just the x and the y coordinates got flipped. Really, so it's kind of like the x and the y axis got flipped, right? So this is what inverse cosine, inverse sine, as well as inverse tan looks like. But that's as much as I'm going to stress about those graphs. Are we in agreement with that? We go with moving on. Fabulous. Here we go. So something that I want to remind you about with these inverse, when do we use inverse? Meaning, let's think back to this. How many people are taking ACT tomorrow? Okay, this will be a good ACT quick trick. If this is 3, 4, what's the hypotenuse got to be? Yes. What if this was 5, 12? What's the hypotenuse have to be? Well done. That's just a quick Pythagorean theorem. So that's a Pythagorean triple. Let's say I wanted to find this angle. Does anyone remember how to find an angle in a right triangle? We could go a little SOHCAHTOA. What do you want to use? We could use sine, cosine, or tangent. Doesn't bother me. You want to go sine? Sine of what, Dean?
X equals 4/5.
You guys agree with that? Sine is the opposite over hypotenuse. Okay, how do I get x by itself here? This is when we do that inverse. So I'd say x is the inverse sine of 4/5. So the only time we do inverse, you guys, when we're using these inverse in this arc, is when we're finding angles. Okay, I'm not going to have you guys type this in because on your calculators, you're all going to be in radians. But because I'm in degrees right now, I just don't want you to change yours. I would get this angle to be 53.13 degrees. So you guys, so let's talk about what the heck these mean. This arc sine is just saying inverse sine. This is the exact same thing, and I think we all agreed we prefer this notation. And anytime you say inverse sine or arc sine, inverse anything or arc anything, they're asking for the angle. And the difference for today is we're asking for the angle in radians all day, but we're just going to do it with our unit circle and not with our calculator. So I appreciate you getting them out, but sorry, we don't get them. Do you guys have a unit circle at the front of that pink packet? You might want to have that easily accessible. You might want to take it out, Lizzie, or you do you. But we're going to want to be able to call on it a lot. So, Hen, just like you reminded us, sine is which coordinate, x or y? Sine, right? So what they're asking for, since it's arc sine or inverse sine, they're asking for at what angle is the y equal to negative root 2 over 2? At what angle? And when we're talking angles now, you guys, you're going to want to say degrees. And I'm going to say, can you give that to me in radians? Okay. So at what radian angle is the y coordinate negative root 2 over 2? And I've got a unit circle here. Where's my y coordinate negative root 2 over 2?
7 pi over 4, 5 pi over 4.
He says 5 pi over 4. I see a y coordinate negative root 2 over 2. And 7 pi over 4. We agree with that. Okay, could someone give that to me in negative terms? How could I get to that spot in a negative radian?
Negative pi over 4.
Yeah, isn't 1/4 of a pi up there the same distance in the negative direction would get me negative pi over 4? And here's why I'm stressing that. If I were to type this equation in to my calculator, not that I want us to work with calculators, but check this out. If I did inverse sine negative root 2 over 2, oops, get rid of that, negative root 2 over 2. Oh, shoot, because it's in degrees. Hold on. They just did negative 45. Let me change mine to radians and see what it says. They did negative 0.78. Well, guess what that is? Negative pi over 4, right? Now, what is 7 pi over 4? 7 pi over 4. Okay, so the domain of the function is going to give you this one. But am I good with all three of them? Certainly. Okay, so don't you stress. Let's try another one. Again, when we're seeing the inverse, that's when I want to worry about the angle. When I'm not, I can just worry about the x-coordinate. Because you agree, this is just saying, what's the cosine at pi over 2? What's the x-coordinate at pi over 2? What do you think, y'all? X-coordinate pi over 2, perfect. So then I'm going to replace inverse sine, and I'm going to say 0. Whenever it's got the inverse or the arc, they're asking for the angle in terms of radians. Sine, the y-coordinate, is 0 at what angle? The y-coordinate is 0 at what angle in radians? Ooh, I like that. He's saying all the way around. I got a 2 pi. Anywhere else?
Negative 3 pi over 2.
At negative 3 pi over 2, the x would be 0.
Oh.
Yeah. Say that again. 0. Do I even have to go all the way around? I could just start there. Love that. Anywhere else? Say that again. Pi. Love it. All these are great. Which one do you think that my answer key would probably say?
0.
Exactly. The most simplified one. Goes back to that domain. Russell, you're good?
Yeah.
Great. Okay, how about this guy? This one's saying, hey, let's start in the parentheses. Whenever it's inverse or arc, it's asking for the angle. At what angle is the tangent, which we know is y over x, 1? Y over x, 1.
Pi over 4.
Pi over 4, root 2 over 2 divided by root 2 over 2 would be 1. You guys agree with that? Could Lexi have said, oh, how about a 5 pi over 4? Negative root 2 divided by negative root 2 over 2, that would get me 1 as well. But again, we're going to go with our answer in the first quadrant when we can. What about inverse sine of 1?
Pi over 2.
Yeah. At what angle is the sine, the y coordinate, 1? We're going to say pi over 2. I'm down with that. Okay, peeps. Now we got to go some mental math. Pi over 4 divided by pi minus pi over 2. 1/4 minus 2/4.
Negative 1/4.
Yeah. 1/4 minus 2/4 is negative 1/4. Are they asking for the angle here? No, they already gave us the radian. They're asking for that y coordinate. Sine, the y coordinate at negative pi over 4.
Negative 2 or root 2 over 2.
Yeah. Instead of going up 1/4 of a pi, I'm going to go down. And that y coordinate is negative root 2 over 2. So on this one, it's saying the x coordinate is negative root 2 over 2. Where? He's saying 3 pi over 4. Where else?
Pi over 4.
Yeah, which one do we want to go with? 3 pi over 4. Agreed, Henry. So we got cosine, a 3 pi over 4, minus a pi over 2. That pi over 2, I'm just bringing it down. 3/4 minus a half. 3/4 minus 2/4.
Pi over 4.
1/4. So the cosine at 1/4 of the pi.
Root 2 over 2.
Cosine is the x-coordinate at 1/4 of a pi. We're saying root 2 over 2. Agreed, Mr. Thompson. So now on this guy, ooh, this is when we mess him up the most, y'all. This is when we mess him up because we think they're saying, what's the x-coordinate, right? So be careful. Anytime we're given an arc or an inverse, they're asking for the angle. They're asking for the angle. At what angle is the x-coordinate? -1. What we got? 180. In terms of radians? Pi. Very good. They're asking for the angle anytime they've got an arc or an inverse. Okay. Arc tan of 1. Are they asking for an angle? Yes, Henry. Say that again. You're okay, because you're saying at what angle is my y over x going to be 1? Root 2 over 2 divided by root 2 over 2 is going to be 1 at pi over 4. Could there be another answer? Yeah, he's like right over there, but I'm going to stick with the first quadrant. Love it, Hen. Us getting more comfortable without the unit circle will be a great help come next year. You don't have to be there yet if you don't. If you're not, that's okay, but I just like to make us aware of it. Get over here. Okay. You guys, what about, I can't move this. So inverse sine, arc sine of -1/2.
7 pi over 6.
At what angle, and I like that you gave me pi because that'll give me an angle, is the y -1/2? The y is -1/2. Where'd you say that, buddy?
7 pi over 6.
True. Where else?
11 pi over 6.
11 pi over 6. Which one do you think I'd prefer? Which one's closer to this first quadrant? Which one's closer to my starting point, that axis? Yeah. So I'm going to prefer the 11 pi over 6. Give it to me in negatives. Yeah, that's what my top dog is. But, so you're going to see this on your homework. Will I accept either of these? Yeah, on the key, I'll probably only put this one. But if Henry's like, I know that this gets me to the same exact spot, you don't need to change your answer. Just knowing yours is equivalent is all I care about. Okay, last 3, y'all. Inverse sine root 3 over 2. At what angle is my sine root 3 over 2? Yes, sir. He said my y is root 3 over 2 right there at pi over 3. How about this guy? What is the sine at pi over 3? Switched it up on us this time. What is the y coordinate at 1/3 of a pi? Root 3 over 2. So then they're asking inverse cosine of root 3 over 2.
Pi over 6.
So it's asking, yeah, at what angle is my x root 3 over 2? You're saying pi over 6? I dig it. Love it. Last one, peeps, and then I'm just going to have you practice a little bit. Here we go. At what angle is the sine 1? Pi over 2, well done. So I got the tangent just chilling. I got a pi over 2 there. Minus, at what angle is the x 1/2? Pi over 3? What do I need in order to add or subtract these fractions? Common denominators. What do we want to make those denominators? Love it. So how many sixths would I have to be the same as 1/2? 3/6. Very good. Yeah, I got you. 3/6 minus 2/6 leaves me with 1/6. You do not need to show me those steps if you can just get there. Maybe using some mental math. So now they're asking, what is the tangent at pi over 6? What is my sine gerene over my cosine gerene? What is my y over x?
Root 3 over 8.
Yeah, he's saying, okay, this is the long one where we got to do 1/2 divided by root 3 over 2 My 2's cancel. I'm left with 1 over root 3. I'll get rid of those root 3's out of the top and the bottom. And we're left with root 3 over 3. Well done, Tomps. So I'm going to ask you to do pages 33 and 34. Look at 34. Boop! I got an answer key. Hey! Again, if your answer doesn't match mine, I'm just most curious, is your answer equivalent to mine? So instead of saying negative 11 pi over 6, you could say 11 pi over 6. I don't know if I just said that wrong. They're the same thing. I'm just giving you one of the answers. So I'll leave my answers blown up here so that you can just reference those instead of having to flippity-dippity. And we'll be walking around just asking if you need any help as we go. I'm not going to put my thorough answer key up. It is right here if you want to look at it. But just holler at us. There's 2 of us now. There's no need for any question to go unanswered.